Hi viewers, welcome to Learning Electrical Engineering channel. In this video, we will see about Thevenins Theorem. The Thevenins Theorem was first invented by a French telegraph engineer, Leon Charles Thevenin. This theorem is stating that any two-terminal bilateral linear DC network can be converted into a voltage source in series with resistor. Now the voltage is the open circuit voltage at the terminals and the resistance is the equivalent resistance of the circuit. Now for better understanding of this theorem, we have considered a circuit. This is the original circuit. This portion is original circuit and this circuit is the Thevenin's equivalent circuit. To draw the Thevenin's equivalent circuit, we need to know the values of Thevenin's voltage or the open circuit voltage and the equivalent resistance or the Thevenin's resistance. First we will find out the value of Thevenin's voltage. To find out the Thevenin's voltage from the original circuit, we need to remove the variable part of the circuit. In this circuit, if you are seeing here, the RL is the variable, rest the shaded portion of this original circuit is the fixed one and this is the variable one. Now we are going to convert this fixed portion of circuit into a voltage source in series with the resistor. To do that, we need to remove this variable part, that is RL resistor, and we will find out the voltage across the A and B terminals. Now to find out the voltage across this A and B terminals, we need to apply the mesh and nodal analysis so that we can find out the voltage across the R3 resistor, and this voltage value across the R3 is equivalent to ETH, VTH or the open circuit voltage or the Thevenin's voltage. Now if we are applying the mesh analysis, in this condition, if current I1, we are marking the loop current I1 and loop current I2, then the voltage across R3 resistor, that is VTH or ETH or open circuit voltage is equal to, we can write I2 into R3. Now this is the voltage which is equivalent to open circuit voltage. This is the method to find out the open circuit voltage at terminals A and B. On the next step, we need to find out to draw the Thevenin's equivalent circuit, we need to know two parameters, that is Thevenin's voltage and Thevenin's resistance. We have found the value of Thevenin's voltage. Now we need to find out the value of Thevenin's resistance. To find out the Thevenin's resistance, we need to find out the equivalent resistance of the circuit by looking from the open circuited terminals. Now the circuit may have the independent sources only, the circuit may have dependent sources only, or the circuit may have both of them. So on first case, we will consider the circuit is having only independent sources, only independent sources. Independent sources. In this case, we need to turn off the voltage and current sources by short circuiting and open circuiting accordingly. For turn off, in case voltage source is there, then we need to short circuit with internal resistance if internal resistance is available, otherwise we can directly short circuit it. In case of current source is available, then we need to open circuit the current source, then we can finally find out the equivalent resistance. Now in this case, the voltage source is available and internal resistance is not available, then we can directly short circuit it, then we can find out the equivalent resistance by looking from the open circuited terminals. Now we can find out one value, or RTH. Next, case 2. In case 2, if dependent voltage source is available, dependent source is available, dependent source is available, that time it's very difficult to find out the equivalent resistance because the dependent sources are being controlled by the circuit variables. Now we will draw the for better understanding, we will draw the one dependent voltage source plus minus 3 Vx and the voltage across R2 is Vx. Now in this case, what will happen, the dependent voltage source is controlled by a circuit variable, that is voltage and current. So during that cases we need to inject the voltages. So inject the voltage V0 from this terminals, that is A and B, then we can find out the value of I0. From these two parameters we can calculate the Thevenin's equivalent resistance RTH, that is V0 by I0. If we are having the current source, that time we can inject the current source and then we can find out the value of V0, that is voltage across the open circuited terminals, and then we can calculate the equivalent resistance value by using this formula. So the dependence we need to inject the voltage or the current to find out the equivalent resistance. Equivalent resistance. Fine. On next step we will draw the equivalent circuit. So for drawing of this equivalent circuit, this is the original circuit and this is the equivalent circuit. We have found the ETH value, we have found the RTH value. Now we have drawn this like this. Now the terminals A and B, initially we were removed the resistor RL, now we need to connect it back. So when we connecting back the RL value, the current flowing through the resistor, variable resistor, can be easily found. Now the current flowing through the resistor RL, general formula for current I is equal to V by R. Now V in this circuit is ETH, so IL is equal to V is ETH, and the resistors available in the circuit, available in the Thevenin's equivalent circuit is RTH and RL is available. So we can write RTH plus RL because both are connected in series. Now we can find out the load current flowing through the load resistor. Now the advantage of this circuit is a very complicated, a very big circuit, a very complex circuit can be converted into a voltage source in series with one resistor, so that we can easily calculate the circuit variables when the load is varying. Now if we want to find out the value of voltage across the resistor RL, then VL is equal to, the general formula is equal to V is equal to, general formula for voltage V is equal to I into R. Now for load voltage VL is equal to I is equal to IL in this case. Now IL is equal to ETH divided by RTH plus RL, and R is equal to RL. This is how we can find out the values of voltage across the load resistor or current through the load resistor. If the resistance is variable, then we can vary the values here, then we can easily find out the required circuit parameters for analysis purpose. Now one more point we need to understand is the characteristics at terminals A and B of the original circuit and the Thevenin's equivalent circuit is quite same for voltage and current. Exactly same for voltage and current, we can say. The internal characteristics of the original circuit and the internal characteristics of the Thevenin's equivalent circuit usually quite differ. If you like this video, kindly hit the like button below this video. If you have not subscribed my channel, kindly subscribe it. Thank you so much.